This is a lab scope pattern of a recliner motor in a power seat. To see what happened is right down here, it was off, and this is where we hit the switch to start the reclining. As you'd expect, it spikes up a little bit and then it runs along here at about 2 to 3 amps as reclining, and then at this point right here, something happened. We're looking at current here. Over on this left-hand side, you can see that this is 60 amps at the top. And right here, it went from about 2 to 3 amps instantaneously up to above 60. So if we zoom in, try to get that on the screen here so we can see that. You can zoom in even more. Go in even more and look at these little bumps here are the commutator bars. This is where the brushes are touching the commutator. As you look at it, they're pretty consistent. I mean, there's some variability there, some variation, but it's pretty consistent. That motor's spinning, and it's going around and around. It's functioning perfectly until right there. The question is, why did the current go high? Did the motor bind? I would say no, because if the motor had bound, it would have gradually been increasing as the motor bound. And the motor came to a stop. It didn't do that. It just instantaneously shot up. I don't know what this means, but at this point I would suggest that maybe a wire shorted as the seat reclined back. It reached a point where the metal frame touched a wire. Something happened and instantly it went from 2 amps. See over here, we're working at about 2.5 amps to up more than 60 amps, and that's where it blew the circuit breaker. Up off the screen here at 60 amps.